Here, the PN junction diode, when you come to circuits, how to draw the circuit means the circuit symbol of PN junction diode. Like a capacitor means we give some circuit symbol like this, na? Resistor means we give some circuit symbol like this, na? Okay. And in the same way, inductor means we give some circuit symbol like this, na? Battery means we give circuit symbol like this, na? In the same way, what will be the circuit symbol for PN junction diode? Okay, that circuit symbol here I am drawing. The circuit symbol is means first point what we are taking here. The circuit symbol of PN junction diode is that circuit symbol I am giving here. It is represented like this, nano circuit symbol, like one arrowhead. This is the arrowhead, and with a plate like this. It is the circuit symbol of PN junction diode. In this circuit symbol, if you see, who is this arrowhead? Arrowhead represents whom? If you ask, it represents P side, nana, and the plate represents here the N side. Okay. So here, if you see the PN junction diode, okay, the circuit symbol here is, nana, who is this reconnecting in your group? Okay, right. Okay, right. In this forward bias, who are the minority charge carriers, Nana? Electrons.
Electron.
Generally, in forward bias, what I did here, P region is connected to positive, N region is connected to negative, na? In the forward bias.
Yes, sir.
That is high and low, na? So external electric field is applied in this direction, na? So the electrons, the minority charge carriers here will try to move in the same direction or left side. Left side means they are moving in the same region or not?
Same, sir.
Same region moving from one place to another place is called as a drifting, Nana. Okay. Even here also holes, positive charge carriers, they move in the direction of external electric field. In the direction means they move in the same N region towards the ends. They are moving in the same region. They are not interested to cross the junction. That's why here also we say, yes, they are drifted in the same region. This is what I said when the applied voltage is greater than barrier potential. When applied voltage is less than barrier potential, I think there is no doubt. Okay. Majority charge carriers won't diffuse, minority charge carriers, of course, may be drifted to the other region. But majority charge carriers are not diffusing means no need to discuss such point here in case of V less than or equal to VB. Okay. Why? Because some charge carrier crosses the junction, then only the current, whatever coming from the battery, will reach to the other end. Otherwise, it will be like open circuit when no charge carriers are crossing the junction. No open circuit means no current flows through the circuit. That's what we discussed here. When V is less than or equal to VB, no current flows through the PN junction diode, through the diode. Okay, Nana? That's why I think here there is no confusion. First and second points, in the forward biasing of this junction diode. Okay. Diffusion already you understood. Diffusing means moving from one region to another region. Okay, that happens when V is greater than VB. The majority charge carriers are diffused. Yes, holes move in the direction of electric field, crossing the junction and entering into the N region. Electrons are majority charge carriers, crossing the junction and entering into the P region in opposite direction to the electric field. Electrons move in opposite direction to the electric field, holes move in the same direction of electric field. They are crossing the junction, majority charge carriers. That's why it is called as diffusion. Now, Sachin Reddy, your doubt is clarified or not? Right. So, identified the difference between diffusion and drift, Nana? All of you?
Yes, sir.
Yes, sir.
Yeah. Drift means in the same region. Diffusion means into the another region. Okay, right. Simple, Nana. Here, then again, here coming to this example, Nana. This is one silicon junction diode, Nana. Silicon means immediately you have to recollect what is the barrier potential. Okay, that is connected to one DC source. Connected to here, one DC source like this. Okay. How you connected, sir? For preparation only, Ramaditya. Okay. Here connected to one DC source like this. Okay. Here, what I did, Nana? Diode, PN junction diode is connected to a resistor. Suppose this battery is of, say, some 12 volts. Okay. And here, this one is of, say, 1. Okay, I take it as some 100 ohms, Nana. Find the current through the circuit. This is what I'm saying. These type of questions usually they give in exam, right? Then what do you say for this, Nana?
సార్ ఇప్పుడు లోపల అలాగా వేయాలా సార్?
ఇంకంతేగా obvious గా. Resistance for the diode is given or not?
No, sir.
So neglect the junction resistance. Okay, obviously there will be some resistance at the junction, but he did not give it for us. So leave it. Then what you do there?
సార్ అంటే ఇప్పుడు ఆ డయోడ్లోనే మనం ఇందాక చూసిన జర్మేనియం అయితే ఇంత, సిలికాన్ అయితే ఇంత అని ఈఎంఎఫ్ ఇచ్చారు కదా సార్.
Yes.
ఇప్పుడు మీరు క్వశ్చన్ సిలికాన్ అని ఇచ్చారు కాబట్టి మనం అక్కడ 0.7 తీసుకోవాలి కదా సార్.
Yes. And a barrier you are saying, am I right?
Yes, sir.
Yes, correct, Ramaditya also. Yes, in the solution I write VB is equals to 0.7 since it is silicon. Then Nano?
ఇప్పుడు లూప్లో వేయచ్చు సార్.
Loop law applies, so what you do there?
సార్ 12 minus 0.7.
Minus 0.7 or plus 0.7?
Minus, sir, opposite direction.
Right, good. So it opposes.
Yes, sir.
Am I right? Right, okay, good. So net voltage here across the resistor. Okay, right, good. So in forward bias, can I say in forward bias, okay, the net voltage or net PD, better we write like this, net PD across the resistor. okay, is equals to V minus VB. Shall I write like this, Nana?
Yes, sir.
Right. And V is given here as what? 12 volts. This one loop law you are saying. Okay. So this node point I am highlighting. And then coming back to that implies you are saying that 12 minus 0.7 minus IR Anana,
Yes, sir.
minus I into R100 is equals to 0. Loop law you are saying according to loop law. Right, good. That's okay. That implies you are saying that 11.3 is equals to I into 100. That implies I is equals to 0.113 amperes. Correct, Anana? By dividing with 100,
Yes, sir.
that implies I is equals to 113 milliamperes. Okay, good. This type of model they will ask, Nana. Okay, and sometimes they may ask even like this also. What, sir? Here, suppose this was the question given in 2019. Next example here. Uh, this is example 2. Okay. In this example, what he did, this is one circuit. In the circuit, of course, he connected one external source here, and then he connected it to two diodes like this. Here he connected two diodes now. How, sir? Here, parallel. This one you have to think wisely and try to say the answer correctly. Okay. Here, this was one question given. Here he is taking the two diodes like this. That is one diode, Nana. And this was another diode. Okay, connected like this. Connected here. And these two diodes, one is germanium, other is silicon. Okay, connected. Oh, here he connected one 12-volt battery. And here I forgot in drawing resistor. Okay, here he took one resistor like this. This is the resistor he gave. This is 5K kilo ohms. And here this 12 volts negative terminal is connected to the earth. Means here indirectly he is saying that it is 0 and that is 12. Potential difference is exactly 12, what he is saying. Okay. Then what is the current through the 5 kilo ohm? Suppose if I ask, then what do you say, Nana?
Sir, here again, like previous question, those two are in parallel. One is point 0.7, one is point 0.3 VB,
Yes, exactly. Yes, exactly.
and they are in means they are giving currents in opposite same means You have to subtract, sir. 0.7 minus 0.3.
Really? Once you think wisely.
సార్ అవి అంటే సిమిలర్ టు సెల్స్ కనెక్టెడ్ ఇన్ ప్యారలల్ కదా సార్. అవి రెండు అంటే ఇప్పుడు జర్మేనియం సిలికాన్ మనం ఆ డయోడ్ లాగా తీసుకోకుండా ఒక అంటే ఒక మామూలు సెల్ లాగా కన్సిడర్ చేయొచ్చు కదా సార్, ఆపోజిట్ డైరెక్షన్ లో ఉన్నది.
ఎవరు చరణ్
సార్ అంటే అవి ఎయిడింగ్ లో ఉన్నాయి కదా సార్, అప్పుడు యాడ్ చేయాలేమో.
ఎయిడింగ్ దే ఆర్ ఇన్ ప్యారలల్ కదా నాన్న.
అంటే
ప్యారలల్
అంటే ఎక్స్టర్నల్ సోర్స్ కనెక్ట్ చేస్తారు కదా సార్.
అంటే ప్యారలల్ కనెక్టెడ్ టు ఎక్స్టర్నల్ సోర్స్, దెన్ వాట్? ఏం లేదు, సింపుల్ నాన్న. మీరు ఎందుకు ఒక చిన్న కన్ఫ్యూజ్ అవుతున్నారు. ఐ థింక్ హియర్ వాట్ ఈస్ ద బ్యారియర్ పొటెన్షియల్ ఫర్ జర్మేనియం?
0.3.
సిలికాన్ 0.7. correct? Suppose here after maintaining and the barrier potential at the barrier potential 0.3, first of all it will send some current, na?
Yes sir.
At that time directly you can find the current, na?
Yes sir.
This is not sending. Why? Because the barrier potential up to here 0.7 it won't send. Parallel you have to remember that the potential should be same, correct?
Yes sir.
If they give the junction resistance for these two, you can apply like what is the net EMF across the two. Suppose it is E1 and its internal resistance is R1, it is E2, its internal resistance is R2, then net EMF between these two ends, potential difference will be E1 R2 plus E2 R1 by E R1 plus R2. Remember this formula in current electricity?
Yes sir.
Yes, sir.
Yeah, but here problem is the internal resistance is not given, Nana. That's why here when two cells of internal resistance means junction resistance, what I'm saying, the junction resistance is not given. That's why here its barrier potential is 0.3 volts, means it behaves like a cell of 0.3 volts, and it behaves like some cell of 0.7 volts. Since they are in parallel, out of these two, once the barrier crossed the barrier potential, the potential difference across this crossed 0.3, it starts sending the current. It starts sending the current means forcibly it tries to put the potential difference across these two ends as 0.3. Means continuously the silicon is not sending the current, only germanium is sending the current. Now you understood my point, Nana?
Right, sir.
This is what I am saying. Okay, so here since it is 0.3, once it starts conducting the current, it tries to maintain across the diode, means these two ends it maintains 0.3 volts. Maintains 0.3 volts means at 0.3 it won't send the current. Okay, since they are parallel, it can't maintain a separate potential difference. This is one more disadvantage. That's why forcibly the silicon also accepts the barrier potential as 0.3. That's why altogether maintain potential difference is 0.3. Therefore, through the silicon, no current will pass. Now you understood my point, Nana, here?
Understood.
Or if you have any arguments, you can raise. Yes, okay, then here in this question, what he asked, find the current through the external resistor. This is the question. So I am going to write here the solution. What? Since the germanium at VB is equals to 0.3 volts. Okay. VB 0.3. Sorry, better I write like this. At V greater than 0.3 volts passes the current. First you observe, Nana, is it in forward bias or not?
Forward only.
Both are in forward bias actually, right? Right, good.
Yes.
Passes the current. Thus, it forcibly maintains a PD across silicon diode as 0.3 volts. Okay. Thus, that implies germanium diode sends the current, but not the silicon diode. Okay. So if you understood this point here, I can move to the next point. So any arguments, Nana?
No, sir.
No. So here that implies straight away I'm going to V across the resistor is equals to across the resistor is equals to, already I told, when a diode is in series to the resistor, the potential difference across the resistor is V minus VB, I told here. So that is again 12 minus 0.3, not 0.7. So I write it as 11.7 volts. That implies current through the diode, I through the diode. Sorry, through the resistor is equals to, I write here, that is V by R. R is 5 kilo ohms, Nana. So 11.7 by 5 kilo means 10 power 3 ohms. Yes. 2.52 Nana. 2.52 milli kada Ramaditya. 5 2s are 17. 17 means I think 3 ra. This is not 12.3 na. Okay, 5 2s are 10, 17, 5 3s are 15, 20, 2.34 milliamperes. Era my calculation correct or wrong?
Correct, sir.
Correct only, na? Okay, then this is one question. Here what he asked. Okay, previously in exam, that type of model. Now you understood how to solve, Nana?
Yes.
Or do you have any doubt?
Sir,
Understood?
no doubt, sir.
Yes.
Sir, if he gives resistance of diode, then we should use parallel condition.
Yeah. In that case, we can consider these two are two different cells which are opposing the potential of applied, which are opposing the applied potential. Then we use that part. What E1 R2 minus plus E2 R1 by R1 plus R.
Sir,
Okay.
then in that case, it
Yes,
won't means forcibly apply, sir.
yes. Yes. Why? Because internal resistance also there, na?
Yes. Okay, sir.
Yeah. It means
Sir?
that appears. No.
సార్ ఒకసారి ఈ పార్ట్ చెప్పండి సార్, మళ్ళీ జర్మేనియం దగ్గర.
చెప్పడానికి ఏముంది అక్కడ?
అంటే ఇప్పుడు
ఇదేమో సింపుల్ చిన్న లాజిక్ అర్థం చేసుకో. 0.3 దాటితే ఇట్ విల్ సెండ్ ద కరెంట్. Am I right?
ఎస్ సార్.
ఇది 0.7 దాటితే గానీ కరెంట్ ఫ్లో చేయదు.
అవును సార్.
అంటే హూ ఈజ్ సెండింగ్ ద కరెంట్ ఇనీషియల్లీ?
జర్మేనియం
కదా. వన్స్ ఇట్ స్టార్ట్ సెండింగ్ ద కరెంట్ అంటే దీని వర్కింగ్ అనేది స్టార్ట్ అయిపోయినట్టేగా.
అవును సార్.
దీని వర్కింగ్ స్టార్ట్ అయిందంటే దీని ఎండ్స్ మధ్య ఇది ఎంత మెయింటైన్ చేసుకుంటూ ఉంటుంది?
0.3.
ఇది 0.3 అయినప్పుడు ఇది 0.7 ఎలా మెయింటైన్ చేయగలదు?
ఓకే సార్, అర్థం.
అంటే దీని ఎండ్స్ మధ్య ఇది కరెంట్ ఫ్లో స్టార్ట్ అయింది కాబట్టి ఇట్ ట్రైస్ టు మెయింటైన్ 0.3 volts. అదే 0.3 ఇట్ గివ్స్ టు సిలికాన్. ఇది ప్యారలల్ గా ఉంది కాబట్టి.
అర్థమైంది సార్.
ఇప్పుడు 0.3 దగ్గర సిలికాన్ విల్ సెండ్ ద కరెంట్.
నో సార్.
సో అప్పుడు ఏమవ్వాలి? కరెంట్ విల్ ఫ్లో ఓన్లీ త్రూ ద జర్మేనియం డయోడ్. నీకు ఇట్లా వెళ్ళాలి.
ఈ కింద సిలికాన్ బ్రేక్ అయిపోయినట్లు సర్క్యూట్.
అంటే ఇక ఇది సర్క్యూట్ లో లేనట్టు, సింపుల్. మనం చెప్పుకున్నాం కదా, ఇఫ్ వి ఈజ్ లెస్ దాన్ విబి, ఇది జస్ట్ ఓపెన్ పార్ట్ నానా, ఇది ఓపెన్ ఒక కీ లాగా బిహేవ్ చేస్తుంది, ఇట్లా ఓపెన్ అయిపోయినట్టు ఉంటుంది అని చెప్పి చెప్పుకున్నాం కదా. రైట్. అంటే అది జస్ట్ ఓపెన్ కీ అంటే సిలికాన్ డయోడ్ ఉంది కానీ జస్ట్ ఓపెన్ కీ. నౌ యూ అండర్స్టూడ్ దట్ పాయింట్?
అండర్స్టూడ్.
సరే, 11:36 అయింది కాబట్టి ఇంకా ఎగ్జాంపుల్ 3 చెప్పలేను నేను. ఓకే, కమింగ్ టు హియర్ నాన్న, ద పేజెస్